Alright, so section 3.7, implicit differentiation. So we kind of already went through the rules for implicit differentiation. So if you didn't write this down in class, make sure you do so now. So remember that an explicitly defined function is what we've been dealing with, where y is known, y is not hidden, okay? So when we find dy dx, then we're just figuring out the derivative of x for y. Now, an implicit defined function is a function that is not solved for y. That means y is hidden somewhere inside of the function. So we can't really find dy dx of y because y is hidden. Y is unknown. We don't know what y truly equals. So when you have an implicit defined function, to find dy dx, we do have some extra stuff to do. So the four-step process, we already went over this in class. Remember, we're going to treat y as a differentiable function of x, but we're going to add something to it. So step one, differentiate both sides of the equation with respect to x. So that means when you're deriving y, so when y is present, we differentiate it, but then we have to multiply it by dy dx to figure out what y truly is. Step two, we're going to collect the terms with a dy dx on one side of the equation. We're going to factor out dy dx, so that means get it by itself, and then we're going to solve for dy dx. And once we do this, that means we have found the derivative. So first, let's look at finding the derivative of y as a function of x and its relation to using the chain rule. The way that the definition gives it, it doesn't truly use the chain rule the way that we normally would, okay? So this kind of just explains what we're doing to y. So you guys already know this. Basically, if y is differentiable function of x, then d dx, which means dy dx, of y to the n is given by this. So d dx of y to the n is always going to equal n times y, right? You bring this down, and then n minus 1, as we always do, but this time we're going to multiply it by dy dx. Now this is provided that y does not equal 0, and if n is less than 1. We'll talk a little bit more about this when it comes up in an example, okay? So here are some examples. So if you were deriving y to the fifth, exactly what we talked about in class, this would become 5y to the fourth, but we're going to multiply it by dy dx and then continue the problem. If this was present, it would be negative 3y to the negative 4 times dy dx. So nothing too difficult. And then of course, if y is raised to 1, then the derivative of that is just going to be 1 times dy dx. Okay, so we already did this problem in class. So I'll just give you guys a second, pause the video, and write it down if you haven't done so already. And let's go on to number 2. So number 2, it's very similar, except it has a trig. So we know that this is implicit differentiation because y is kind of everywhere. So when we're deriving, when we're trying to find dy dx, the x's, you derive them like you normally would. So what is the derivative of x? It's 1 plus. Now here it's the derivative of sine of y, so we're still going to derive it, pretending it's an x. So that is just going to be cosine of y, but remember we're going to multiply it by dy dx. And then equals this guy, it's x times y. So how do we derive something that is multiplied? We use the product rule, which is the derivative of the first guy, which is x. so because it's an x, we derive it normally, and that's 1, times y as it is. You know what, the way we usually do it in class is we take the first guy times the derivative of y, which is 1, but because it's a y, we have to multiply by dy dx, plus the second guy, y, times the derivative of x, which is just 1. Okay, we're going to clean this up a bit. So this becomes 1 plus cosine of y dy dx equals x times 1, which is x dy dx plus y. Alright, step 2, get the dy dx stuff together on one side. So I'm going to move this 1 over here, and I'm going to move this guy over with the cos. So this becomes cosine of y dy dx minus, because we're moving them over to this side, x dy dx equals y, and then minus 1 because we're moving over the 1. Alright, step 3 is factor out the dy dx's. I'm just going to move over here. So that means dy dx, when you take that out, what's left is cosine of y minus x equals y minus 1. And now you just solve for dy dx. Now because this is multiplied by this whole entire thing, we're going to divide by this whole entire thing. That cancels out on this side, so we're left with dy dx equals y minus 1 over cosine of y minus x. Done. Alright, example 3. So again, same thing. Y squared, because it's a y, we're going to derive it, but we're going to multiply it by dy dx plus another y, so the derivative of 2y is 2, and we're going to multiply it by dy dx equals the derivative of x, which is 2, plus the derivative of 1, which is 0. So now the dy dx's are already together on one side, so we don't have to put them on one side. We can skip step 2 and go on to step 3, which is factoring out a dy dx. And we're left with 2y plus 2 equals 2. And now we divide both sides by 2y plus 2. Remember, this is being multiplied by this whole thing, so you can't subtract 2 and divide. Okay, you have to divide by the whole entire thing because it is one term. So that is gone, and we're left with dy dx equals 2 over 2y plus 2. Now I can simplify this a little further because there's a 2 in every single term. So the final answer, if we take out a 2 from the top and a 2 from the bottom, and they cancel out, so we're left with 1 over y plus 1. Okay? Alright, next example says find the second derivative for example 3. In example 3, our answer, the first derivative was 1 over y plus 1. So we have to find the second derivative of this guy. So obviously this is a division problem, so I'm going to use the quotient rule to find the derivative. Remember, you start at the bottom, you take the bottom guy as he is, which is y plus 1, times the derivative of the top, which is what? 0. Okay, I'm just going to write it in. I know this ends up canceling out. Minus, big parenthesis, the top times the derivative of the bottom, and what's the derivative of y plus 1? It's just going to be 1. And then all of that is going to get divided by the bottom squared. So what happens to y plus 1 times 0? Anything times 0 is 0. So what we're left with is negative 1 times 1, which is 1. And then all of that gets divided by y plus 1 squared. And that is our second derivative. Alright, I just made a massive mistake on this one because we are finding the derivative with respect to x. And you notice here there is no x. Oh, sorry. We're going to have to erase this. I didn't pay attention to that. So we want to find the second derivative with respect to x. So that means you're still using the quotient rule. Now, it's the bottom times the derivative of the top, that stays as it is, minus the top times the derivative of the bottom. But the bottom, because this is a y, we have to take 1 and we're going to multiply it by dy dx. So now, all of that is divided by y plus 1 squared. So of course this is gone and we are left with negative 1 dy dx over y plus 1 squared. So now how do we get that dy dx by itself? Remember that on this side there is a dy dx because that was there from the beginning, right? This right here is the same thing as writing dy dx. So we're going to multiply both sides by y plus 1. Squared. Y plus 1 squared. This is just basic algebra. So that way we can get to this guy right here. So now this becomes y plus 1 squared times dy dx equals negative dy dx. Alright, I'll be honest with you. Looks like it's supposed to end up being 0, but I'm not 100% sure that I'm doing this correctly right now. So let me do this in another video and then we'll come back to it. Okay? So let's just stop here. We'll come back to it. Alright. The next part is finding the tangent and normal line to a circle or an ellipse. So first they want us to graph this function. Remember, this is a circle. So remember that this is your radius. It tells you what your r is. So when we graph our circle, we know that the radius is what? It's going to be 5. I'm not going to review this because you guys should already know what this is. So the radius of the circle is 5. That's an ugly circle, but it's fine. And remember that the circle, the equation is given by two parts. Okay, there's the top part is given and the bottom part. So if we solved for y, it's going to end up being y equals plus or minus 5 minus x, the square root of 25 minus x squared. So this part is equal to y square root of 25 minus x squared, and this part is equal to y negative square root of 25 minus x squared. And if we wanted to find the tangent line, let's remember, when you find the tangent line, you have to first find the derivative, which means we have to find the slope in order to find the tangent line. And we're focusing at this point right here. So that means that they are giving us our x and our y, and we can find the derivative of this implicit function. Okay, we could solve for y in this one. We could solve for y, and then we'd have to find the derivative of this guy right here. But it's actually much easier. So remember that when we use implicit differentiation, we also use it for times when it's inconvenient. So because of this radical, and we are going to end up having to use the chain rule, it's easier to find it using implicit differentiation. So you can use an implicit differentiation if you have an equation that looks like this as well. Okay? So when we're finding the derivative, and the reason we're finding the derivative is because we need the slope, and remember the slope is given by the derivative. So let's find the derivative of this. The derivative of x squared is just 2x, plus the derivative of y squared, which is 2y times dy dx. And then the derivative of 25 is just 0. So now we're going to get dy dx by itself. So that means I'm going to subtract 2x from both sides. So we're left with 2y dy dx equals negative 2x. Divide both sides by 2y. So dy dx equals negative x over y. So what is the slope? Here's my x and my y. So the slope is, I would plug in my x and my y, and that will give me my slope at that function. So it's going to be negative 3 over negative 4, which ends up being 3/4. So that's my slope. So let's find the tangent line. You guys should be able to do this one in your sleep. Remember, it's a tangent line, so it's y equals mx plus b. What's my y? It's already been given. It's 4. What's my x? What's my slope? It's 3/4. And my x is 3 plus b. You solve for this, you end up with negative 25 over 4 equals b. So the equation of the tangent line is y equals 3/4 x minus 25 over 4. Okay. Now what's the equation of the normal line? Remember the normal line, the slope is now going to be the opposite reciprocal, so it's going to be negative 4 over 3. My x and my y are still the same. They're still going to be 3 and negative 4. So y is negative 4. Oh, that should have been a negative. You still get the same answer. I already did the math. Equals negative 4/3 times 3 plus b. So we'll work this out together. So this ends up being negative 4 times 3 divided by 3. So what happens to those 3's? They're gone. Plus b. Add 4, add 4. So what's your b? 0. So what is the equation of the tangent line? Y equals negative 4/3 x plus 0. But we don't have to write that plus 0 because it's plus 0, and that's the equation of the normal line. So if you look in the book, they do show you how to get the derivative of this by solving for y and then using the chain rule. And you'll notice that this is much easier. So sometimes implicit differentiation is definitely easier than what we've been doing. All right, enjoy.